In this lesson, we're going to do a few word problems that are typical of the kinds of questions that you could be asked to involve fractions. They're actually very similar to questions to the word problems that you may have done earlier, depending on which program you happen to be in. So we're going to just kind of review some of the principles of solving word problems, a few strategies, and then we're going to review all of the fraction operations using order of operations. So we're only going to do 6 questions, so hopefully this won't take us too long, although I always find when it's word problems, it does take a little bit longer to work through the lesson. So the first thing I want you to keep in mind as we work through is, what do we need to do for word problems? First of all, plan to read the problem more than once before you solve. Try to relate or visualize the scenario. So if you can diagram it, try to diagram it. Use logic to see if your answer makes sense, and always make sure you've answered the question in the problem. Most importantly, don't give up before you've tried. Try it. If you get it wrong, you get it wrong. Now, if this is an online quiz on SAM, you have up to 5 attempts on a quiz. So if you happen to see something in a quiz and you don't get it the first time, don't panic. Let me know, talk to me, and I can help you troubleshoot. Sometimes it's just a matter of how it's typed in, and I can edit that from the back end and give you the extra marks. Other times it may be one of your errors, and we can figure out what that happens to be. But always try it. Once you've tried it, I can understand where your problem might be. All right, so for the first question we're going to look at, we have 3 pieces, 14 and 7/8 inches long, cut from a board that had a total length of 60 inches. How large is the piece left over after all 3 pieces are cut? So you've got a board, it could be a piece of pipe, could be anything, and we're cutting it into sections. 3 pieces are 14 and 7/8 inches long. And I want to know, if you started out with 60 inches, what size is the piece left over? Right? Very classic questions. As you'll see, this kind of question show up several times in the next few sections, especially when we get to conversions, you're going to see some of this. So to do this question, first of all, I always like to pull out the information from it. Now, if you want to, you could sketch it. So I'll show you a diagram that you could use. So we could say, sorry, my drawing abilities on this thing are limited. So we could say, well, this is 60 inches, and we're going to cut 1, 2, 3 pieces, and we want to know what's left, and this is 14 and 7/8, and this is 14 and 7/8, and this is 14 and 7/8. So there's one way to classify your information. You might not have drawn a diagram. What I will often do is I'll say I have 3 pieces that are 14 and 7/8 inches long. So 3 times 14, 3 by 14, 7/8. So I often see it written that way. And then what's left? Okay, so this here kind of like information. So exactly the same information here. It's written out in word form. Here it's drawn out in a picture. You can choose whatever happens to be best for you. Now we need to stop and we need to go back and do some math. So the first thing we're going to have to find out is, what did we use? So the amount that we used, how much did we use? Well, I used 3, 5, 14, and 7/8 inches. Okay, 3 pieces at 14 and 7/8 inches. It's a multiplication question. 3 pieces all the same. You could have done it with addition. If you would like to do it with addition, you are more than welcome to take that route. So the first thing we need to do is get rid of our improper fraction because we're multiplying. So we have 3 times, I said get rid of our improper fraction. I meant get rid of our mixed number fraction. So 3 over 1, turn that into a fraction. And then 8 times 14 plus 7 gives us 119 over 8. Multiplying those together, 119 times 3 leaves us with 357 eighths. Now, this is a terrible way to do inches. If you can imagine somebody giving you that for a measurement, it doesn't look very nice. So I would suggest at this point it could be really useful to turn it back into a mixed number, because it's also going to tell you if your number makes sense. So 357 divided by 8 leaves us with 44.625. So this is my wholes. And then I'm going to take the 0.625, multiply it by the denominator of 8, and we get 5. Sorry, a brain for a moment there that this is my part. Okay, so the 0.625, this decimal, is equal to 5 out of 8. So writing that out, we have used up 44 and 5/8 inches used. Now, if we go back, if you stop here, you haven't given what the question asked, because the question asks, how large is the piece left over? So this is step 1. Okay, step 2, to figure out what's left. Well, I'm starting it with 60 inches, and I'm going to cut off 44 and 5/8. So cutting off is often considered a subtraction question. This is the same as 59 and 8/8 minus 44 and 5/8. 59 minus 44 leaves me with 15. 8 minus 5 leaves me with 3. And that is our final answer. We'll throw our inches symbol in there just to show our units. So we have 15 and 3/8 inches left over. Pretty straightforward question. When you have these multiplication ones and the numbers are really large, feel free to use your calculator to simplify them for you if you would like. I totally understand doing that. Just make sure you still have the ability to show your work for them for the few times that you will be asked. And when we get to midterm time, I won't ask you to show your work for every single fraction question, but you want to watch. Some of them will say show work, and some of them will give you the freedom to use that fraction. Example 2. There are 4 equally spaced lights in a room. From the center of the first light to the center of the last light, the distance measures 187 1/8 inches. What's the distance between the centers of each light? Leave your answer as a fraction. I say leave your answer as a fraction because if I don't, sometimes people will give me decimals, and I want a fraction as our answer. So the first thing I would do for this one is, once again, I would diagram it out. So we have 4 lights. So there's my 4 lights. From the center of the first to the center of the last, we have 187 1/8 inches. Right? I need to figure out what's the space between one light. Okay, so all the spaces are equal. So the reason for diagramming this one out is you'll notice there's 4 lights, but there's only 3 spaces. And that's something that often gets missed in questions. So never be afraid if it's something with equally spaced holes, do a little sketch, even if you only sketch part of it. And it will often be helpful in determining how many holes versus how many spaces. Typically, there'll be 1 less space than holes or 1 less space than joists. So that's something you can keep in mind as you're doing your questions. So we need to divide 187 1/8 inches into 3 equal sections. So division question. 187 1/8 divided by 3 equals, well, most important thing we have to do first is take our improper fractions, or take our mixed number fractions and turn them into improper fractions. 8 times 187 plus 1 would leave you with 1,497 eighths divided by 3/1. Now remember, we're going to flip. Okay, we're going to flip this section. So that's going to give us 1,000 1,497/8 times 1/3. 1,497 times 1 is just going to stay the same. 8 times 3 is 24. All right, now this is a great spot for you to use your fraction button on your calculator. If you use the fraction button on your calculator, take note that it will reduce it for you as well. So you may not end up with 24ths on the bottom. I'm going to actually do this out the long way. So we'll take 1,497 divided by 24 gives me 62.375. Okay, so there's my whole. Take our decimal, 0.375, multiply it by 24, and that will give me my parts. So that will give us 9, and this is the part. So the part's always going to be our numerator. Gives us a really good review of doing that type of math. Unfortunately for word problems, the math does get a little bit messy just to have realistic sizes of numbers. So you're going to have 62 and 9/24. Now, if you remember, 9 and 24 can both divide by 3. We don't have to touch the whole number. That always stays the same. So 62 and 3/8 inches. All right, so that has us solving that. Let's go ahead and give the next one a try. So 62 and 3/8 happens to be our space between lines. I probably could have wrote a little sentence and something like this. That's sufficient, okay? I'm totally up for just having a few jot notes down so that you know what it was you calculated. Third question, this is our last word problem, and just as a heads up, this question is very similar to a question I typically will ask on a test. So while you do not have this in this question or a question like this one in your SAM quizzes, it's a question that'd be good for you to know how to do because this is a question that is likely to show up on your midterm. You have 3 washers with a thickness of 3/16 inches and a nut with a thickness of 3/8 inches, bolting 2 pieces of metal that are each 1/4 inch thick. What's the minimum length of bolt on which you could stack all the washers, 2 pieces of metal, and the nut? It's a very easy question. And we're assuming we can fully thread the nut on, okay? So I'm not talking about just barely grabbing it. I'm going to fully thread. So let's layer the stack. And the order's really not going to matter. It's going to take up the same amount of space. So I'm going to start out with my 3 washers. 1, 2, 3. So there's our 3 washers. And they're each 3/16 of an inch. Now we're going to throw on 2 pieces of metal. I'm obviously not drawing to scale. This is our metal. And it's 1/4 inch each. And then we throw a nut on the top of that. And the nut was 3/8. Okay, and I want to know if I'm putting a bolt down the middle here. Okay, we're bolting down the middle. My bolt. How long does that bolt have to be in order to go through all of the material? So it's actually a pretty straightforward question. So if we're looking at it, I have 3 washers that are the same. So if I want to know their thickness, we're going to have 3 times 3/16. Plus, I have 2 pieces of metal. So that's going to be 2 times 1/4. Plus, I have 1 nut, which is going to be 3/8. So we've made ourselves an order of operations question. You may have done each of those separately, and that would be acceptable. I've written them all out in one equation. So first of all, let's get rid of the whole numbers, turn them into fractions, so 3 over 1 and 2 over 1, and we'll do our multiplying first. So this one, 3 times 3 gives me 9, 1 times 16, 9 sixteenths. Over here, 2 times 1 is 2, 1 times 4, it's going to leave me with 4, plus 3/8. Now we need to find some common denominators in order to be able to combine all of these. So if I have 9 sixteenths, this one, 4 times 4 is 16, so we can use that. So we'll multiply that one by 4, plus 8 sixteenths. And then this one, we can turn the 8 to a 16 by multiplying by 2, plus 6 sixteenths, equals, I have 16 on the bottom, 9 plus 8 plus 6, leaves us with our final answer of 23. Okay, 23 sixteenths. Well, if I do 23 take away 16, I can only subtract 1 16, so we're going to have 1 and 7 16ths inches. So unless you can get a bolt that's precise to the near 16th of an inch, you'd want at least 1.5 inch bolt. 7 16ths go up to the next half instead of going down. Okay. So you'll have to forgive me because I'm not exactly a tradesperson. There are things that I have picked up over the years. Sometimes when I'll give you a bolt size, it may not be standard. So don't worry about that. That part of doesn't make sense. You might argue with me, and that would be a great spot to write a sentence that I would use 1.5 inch bolt because it only comes in these sizes. That would be perfectly acceptable to argue. And I've had people do comments like that in their word problems when I've been checking before. And I always take that into consideration, especially when I'm answering a question. Just make sure you explain your reasoning. So your reasoning should relate back to the appropriate, proper math. All right, so now we're going to switch from word problems. I'm going to do a couple order of operation questions. They will not take us too long, but just to give us a reminder. So the order of operations applies to all math questions. So we're going to do exactly the same thing as we did with whole numbers and decimals. We want to simplify our answers as we work through the steps. That usually makes the math easier, especially turning things back to mixed numbers before we add or subtract. And we want to keep our work organized so we don't miss steps. It's going to be more important with fractions. So remember, brackets first, then exponents, then you divide or multiply, and then we add or subtract. Pretty straightforward. If you forget that, go back and check the notes on order of operations. So for this one, we're going to simplify. It is 5/6 plus 3/4 divided by 3/5 squared. You'll notice the squared is outside of the bracket for this. That means I need to square the top and the bottom. The whole fraction gets squared. So let's write this out in a little more friendly math way. We haven't done squareds with fractions, but you have done squareds before. So 5/6 and 3/4 divided by, now when we square this, that simply means I'm going to use big brackets. We're going to do 3/5 times 3/5 and multiply it by itself twice. All right, so pretty easy math to do. So now we have 5/6 plus 3/4 divided by 3 times 3 is 9 over 25. Okay, next step, let's do our division. Let's write it out with multiplication. 5/6 plus 3/4, and we're going to flip the second fraction. So the division turns to multiply. This flips over, so we get 25 over 9. Now this is a really great spot to do some simplification in the middle if you want. So I can do, I'm going to actually switch my pen color here. So we're just going to be basically looking at this part next. Okay, so here we have 3/4. I can divide 3 by 3, and there's a 9 on the bottom that divides by 3. Well, let's do that. So we'll divide by 3 here. And we're going to divide our 9 by 3. And we'll just rewrite that equation out. So that means this equation is the same as 5, 6 plus, this would turn into a quarter, times 25 over 9. Now, 25 over 9, 25 over 3, sorry. Let me just pop my eraser out here. I'm just getting ahead of myself. 25 over 3. And now we just multiply. Okay, so we'll simplify it a little bit more. And this is going to give us 5 over 6 plus 1 times 25 leaves me with 25. 4 times 3 is 12. Now this is a spot where I say it's often good to simplify. So let's simplify this piece. And I'm going to write it down here. Okay, so we'll just kind of draw some arrows to keep ourselves organized. So you have 5, 6, and 25 over 12 is equal to, well, 2 times 12 is 24. So I have 2 12s. 25 minus 24 leaves me with 1 left and 1 12th. Okay, so 5, 6 plus 2 and 1 12th. That's the same thing as this fraction. It's going to make it a little easier for us to do some reducing after. So that should be a 12, not a 2. Equals. All right, 5, 6, if we double that, that'll give us 12ths on the bottom. So we're going to do that. So this is the same as 10 over 12. Plus 2 and 1 12th leaves us with the whole number 2 stays because there's no more wholes to add to it. 10 plus 1 leaves me with 11 over 12. So not overly complicated, just lots of little steps. Lots of little steps to review. It really tells me if you understand order of operations and fractions when you can put the whole thing together. All right, let's do the next one. This one we don't have squares. I didn't even put brackets in. We made it easy. So BEDMAS says we're going to do our division first. So we'll start here. 4 over 5 plus 3/8 times 4 over 1. You could reduce in the center here. This time I'm going to skip reducing in the middle. I'm going to pretend we don't recognize that we can do that. So we have 4/5 plus 3 times 4 leaves me with 12 over 8. Now we need to find a common denominator. So let's say we can't remember any of these numbers and we're going to work the whole thing out. We'll switch it, reduce it, do all that stuff at the end. So 5 and 8, what's common between them? Well, 5 times 8 would be 40, so that would be the easy one to do. So we'll do 8 times 5 and 12 times 5, and then we'll take this one and do times 8. So 8 times 4 gives me 32. 8 times 5 is 40, plus 12 times 5 happens to give us 60, and 8 times 5 is again 40. Combining this together, 32 plus 60 leaves us with 92 over 40. Let's think. In 92, there's 2 sets of 40. So 40 minus, oops. Let me just write what I'm thinking instead of what I'm speaking. So I have 92. I'm going to take 92. If I subtract 2 40s, that would take off 80 and leave me with 12. So this is the same as 2 and 12 over 40. And I can divide this by 4, and I can divide this one by 4. So it's going to be 2. Should be a 4. It's going to look like it. 12 divided by 4 is 3, and 40 divided by 4 is 10. So 2 and 3 tenths, which is fairly straightforward. Okay. Again, if you use your fraction button on the calculator, you could actually put the whole equation in with your fraction button. You would do, I'll write out the math steps for you. Take 4, and then you use your fraction button, and then 5, then hit your plus button. It'll keep track of order of operations for you no matter which calculator you happen to be using. Plus, you'll do 3, A, B over C, that fraction. Nope, I got things in there. A, B, C. fraction button, and 8, and then hit divide, and again it'll be 1, and you're going to do your fraction button, and you'll be over C, 4, and then hit equals. And that will give you, they'll give you the reduced answer. So your answer will look something like 2, 3, and 10. And that would be the same as 2 and 3/10. So you can use that as a tool to check your work. Really helpful to know how to use that because it means that you should be able to get everything perfect. Okay? And for a very last question, 6 7/8 minus 5/8 times 1 3/4. So again, order of operations are involved. So the first thing we need to do is we're going to do our multiplication. So in this multiplying, we have a mixed number fraction that we have to make improper. So we're going to have 6 7/8. We're not going to touch that yet. Minus 5/8. 1 3/4 is the same as 4 times 1 is 4 plus 3 is 7 times 7 over 4. Nothing here can be reduced. So it's just going to stay as is. So 6 7/8 minus 5 times 7 is 35 over 8 times 4 is 32. This is the same as 6 7/8 minus, there's 1 32 and 35. So we have one whole. 35 minus 32 leaves me with 3. So 1 and 3 over 32. And now we need our common denominator. So 8 times 4 was 32. So we're going to multiply by 4. So this is the same as 6. And 7 times 4 is 28 over 32. Minus 1 and 3 over 32. We don't even have to borrow on this one. So this is pretty easy for us. So 6 minus 1 leaves me 5. 28 minus 3 leaves me 25 over 32. And that's our final answer. Again, you can check it in your calculator using the fraction button to help you solve. So that kind of finishes off our fraction review. I highly recommend you doing the fraction review quiz. So it's mandatory for most of you anyway, so I'm sure you will do it. And the fraction section is one of the ones that people find the trickiest. So make sure you understand how to do that section well. And if you have any questions at all, please don't hesitate to let me know.